Hello everyone. Think math is all numbers and no drama? Think again. Today we unlock the secrets of a deceptively simple equation. Square root of 2 plus 1 to the power x squared equals 3 plus 2 root 2 to the power x plus 1. It might look innocent, but hidden inside is a twist of radicals, exponents, and a surprising pattern that connects them all. Join me as we peel back the layers of this mathematical mystery, step into the mind of a problem solver, and uncover just how elegant algebra can really be. Grab your notebook. This one is going to be wild. So we're going to go ahead and apply two methods. The first method, we're going to go ahead and log both sides. I'm going to use natural log for this. ln square root of 2 plus 1 to the power x squared equals ln 3 plus 2 root 2 to the power x plus 1. And by using properties of logarithms, we can move these to the front. So x squared multiplied by ln root 2 plus 1 equals x plus 1 multiplied by ln 3 plus 2 root 2. Great. Now, this turns into a quadratic equation because of x squared. So we can kind of write it as a full quadratic. The coefficient of x squared would be ln root 2 plus 1. And then we can bring this over here as ln 3 plus 2 root 2, which happens to be the coefficient of x. And then our constant term is going to be minus, or the opposite of ln 3 plus 2 root 2. So that's our full quadratic. And to solve it, we can use the quadratic formula, right? Probably. So how would you use that though? You would write x equals negative b plus minus the square root of b squared, which is the expression squared, and then minus 4 times a times c. But of course, double negative will turn into a positive. So we're going to have this multiplied by the other ln here, which I can just write as dot, dot, dot. And then the whole thing needs to be divided by 2a, which is 2 times ln root 2 plus 1. So what do you make of this, right? Unless you have this special relationship between these radicals, you're not going to be able to simplify this expression. It's going to be quite difficult. You can definitely use a calculator. You can use Wolfram Alpha, which is probably going to give you the exact solution. But what if you're not allowed to use it, right? So as you can see here, this solution method is kind of quite complicated. So you kind of need to realize one thing that is going to help you a lot, even with the first method. So let me go ahead and talk about that. So that's going to kind of give us a transition into the second method. So our second method is going to use a whole different idea. So in order to understand that, we need to understand the relationship between these two radicals. But do you think they're related? And in what ways, right? So to understand it, we kind of need to look at the second expression probably, because that looks more complicated, or maybe a little bigger, right? So to understand that, we can kind of think of this as 2 plus 1 plus 2 root 2. And if you think of 2 as the square root of 2 squared, and 1 as 1 squared, and this one as 2 times the square root of 2 times 1, what kind of pattern does this fit? Think about it, and you'll soon get there. This is a squared plus b squared plus 2ab, isn't it? And that is equivalent to a plus b quantity squared. Yes, finally, a perfect square, and that's just perfect. So here's what we're going to do. We're going to apply it to this problem. But wait a minute, what is a and what is b, right? A is root 2 and b is 1. So our expression 3 plus 2 root 2 turns into root 2 plus 1 squared. That's just awesome. You probably wouldn't get it from here because this is the expression which you square to get you this one. So it's easier to start with the square and try to kind of reverse engineer that. Make sense? So how do we proceed? Well, we now know that one of the exponents, or I should say base, right? One of the bases is the square of the other, which is super duper helpful, don't you think? So now we're going to rewrite our equation. That is root 2 plus 1. Remember our first base to the power x squared, and the other base, which obviously different. By the way, I forgot to say, this is an interesting exponential equation because the bases are different. Like 3 to the power a equals 5 to the power b. I mean, obviously, you can use logarithms. Wait a minute, it didn't work in this case, right? But in general, when you have numbers like these, logarithms should work. Or you could leave your answer like that. But here we have another idea because the bases are not just different, but they're related, like this. Imagine you had a problem like this. 9 to the power a equals 27 to the power b. In this case, 9 and 27 are different, but they are related because they're both powers of 3. You get the idea? So here's what we're going to do now. We're going to write this as a power of root 2 plus 1. Let's do that, which is the second power. So now we're going to write it as root 2 plus 1 to the second power, and then we're going to raise it to the power x plus 1 on the outside. Of course, that means we're going to multiply the exponents, right? When you multiply the exponents, you get 2x plus 2. Now, this is really cool because we have the same base. Now, you got to check one thing. When the bases are the same, make sure that they're not 1, because if they're 1, the equation is always true, right? So in this case, it's not 1, it's not -1 or 0, which are kind of special cases, right? The trivial cases maybe. So they are different from those, which means the exponents have to be equal. Otherwise, these two quantities cannot be equal, right? So this means, or this implies, x squared equals 2x plus 2, which you can solve easily. Whatever method you use, you can use quadratic formula, but I'd like to use completing the square because it's really cool. So bring the 2x over, and then add 1 to both sides, and you can get that 1 by cutting 2 in half and squaring it. That's the number you need to look for, or the magic number. And now we have the perfect square on the left-hand side. Again, that's perfect. Now we can write it as x minus 1 squared equals 3. Now you got to think about this, a little bit of algebra, right? The square of which number equals 3? And there are two numbers. X minus 1 can be root 3, or x minus 1 can be negative root 3. Because when you square both of these numbers will give you 3. Adding 1 to both sides, you're going to get both of the solutions. And since this is a quadratic equation, it should only have two complex solutions. By the way, I say complex, but real numbers are complex too. So you got to be careful about that, okay? Basically, we get two solutions. As you can see, this method is much better than the first method. But if you knew with the log method, right? Remember, after we logged both sides, we got something like this. Let me rewrite that part. So after logging and using properties of logarithms, we got this and that. And now we can go ahead and use the fact that this is actually root 2 plus 1 squared. But when you have another power, what happens to it? You can move it again, right? So this 2 will be moved. It'll become 2x plus 2. And then it'll equal x squared, because you're going to have the same thing here, which brings us to the exact same point. Make sense? So these are the solutions, and that's pretty much it. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.